Ahmedabad. He has his own office there. But basically, he's from Baroda itself. He's from Baroda. I think last time 15 is working from. Okay, you are recording. Okay. So last 10-15 years he's been working in Ahmedabad. He's AWS and Red Hat channel partner. And today our main topic of Maven from zero to hero is going to be taken by Mr. Ravi Soni. And yes, I think we are a bit late, but let's start. I'll hand it over to Ravi. And Nilesh,
anybody attending first time? Most of you are first time, right?
Yes. That's great. So we are for a 50-50 house.
Yeah, so please, Ravi, you can continue.
Okay, so I'll just, let me brief what we do actually.
We want to start a YouTube channel and we want to upload it so people know what we're doing here.
So what we are doing is, it's a kind of, community group. It's basically for all, driven by the community, for the community. So everything by the community. So anybody wanted to present, if you are expert in any of the topic, you can present, and we're happy to give the stage. So it is nothing like AWS definitely support, but run and governed by the community only. And so Ravi sir has agreed. He has attended few of our meetup, and he want to share something. So we have done many sessions, and last around 4 months we started in-person sessions, and last month we did container hands-on. So it was around 6 hours long actually, hands-on session. So we had container starting from very basic to everything, and we have given platforms so everybody can try and experiment containers. So that was our last month. So to continue with the container, he suggested kind of once we understand container, let's go for CI/CD, and ECS is one of the services for AWS, or ECR is container registry. And we want once you understand the container, we wanted to go for kind of code pipeline, maybe AWS or maybe anything. Fundamentally, we wanted to understand how to build, how to run, what is prerequisite, and do it right. Then probably we also wanted to do complete slightly one step more, ECS and Kubernetes. So either go for EKS or we'll continue this series, right? So over to you. Thank you.
Yep, thank you very much. My name is Ravi Soni, and I do software programming for a living. So that is what job I like, those technical things. And so today's topic is Maven 0 to 0. We'll introduce the CodeCommit, we'll introduce artifact. This is the repository where you store your artifacts, Maven artifacts and all the stuff. And then your container registry all together in a fully automated way. The main topic is people knows the Maven is kind of clean, install, and nothing more than that. Okay, but this tool is very detailed. Okay, it was developed on solving such a complex problem of the software building. And then over the time, it evolved to be a mainstream. If you go to this Wikipedia page, okay, there is one graph, and you can see that from 2007 and 8, okay, now the numbers of artifacts maintained by Maven registries in probably comes from millions. Okay, you can see the curves that goes up, and then now all other registry if you see this, the NPM registry, okay, or the PyPy for a Python, or the NuGet for a .NET, they all inspired from this base. So this is what the people have started and shown that how you can do the build management, how you can do the dependency management, and then from all other build systems, and then they were all based on these principles and fundamental of maintaining registries, artifacts, versionings, name, and all the stuff. So this is today's topic, and I encourage the questions in between. Okay, not at the end, because people forget it. If you ask the question in between, we'll able to do more deep dive, and then we'll able to address more questions with the further the clarity it's required. Okay, but after this session, you can definitely add and update your resume that you know Maven and you can work Maven. Okay, so we'll move to the next slide. So this is today's agenda. we'll start with the history, okay? How the systems were derived and from who thinks it and how they did it, okay? Then we'll talk about what is Maven in internals and all the slide setters and all this stuff. We'll go with this all like GAVs, phase, goals, plugins, packaging, profiles, the entire sections of the Maven. We'll go with the repository, like how Maven manages repository, how we interact with the repositories. We'll go with the setup, so we'll do the hello world here. And then we'll move that how the Maven can work with the CodeCommit, CodeArtifact and ECR from the AWS. So this is what it goes that you integrate the other services, okay, with the Maven, okay, and then leverage that you manage the code in the AWS. You build software in the AWS, you manage your artifact here in the CodeArtifact, okay, and then you manage your container using this artifact and manage it to the ECR. And then from the ECR, you deploy directly to your production environment in the one click, okay. One click means literally just one button press, okay, nothing more than that. So we'll walk through the individual setup, okay, and then how it integrates with the Maven at the different configuration aspects. We'll show you the most important thing here, the end-to-end release process. Okay, I don't know like if you have heard or not heard, Maven has the entire end-to-end release process where you line one as a command, okay, and then it does everything for the code building, code compiling, the code tagging, then uploading the artifacts, building the ECR, and so on. Whatever you want to do at that space, it's do it. This is most interesting thing. I worked over like hundreds of project building using Maven, and then over the time, I have built so many cool things using a Maven. Okay, and this is what I'm gonna show you with the how you can manage your software and the licenses and all those things with the Maven. Okay, I'll talk about some of the important plugins that you should definitely try. Okay, and that can solve a lot of your problem when you do your project building. Okay, we'll speak about some of the best practices that I have learned over the time to implement the Maven at the large scale. Large scale is like if you have 100 projects and builds concurrently working. And how you control those, that scale. I don't not about one project, but you can go with that bigger scale for the entire company. Okay, and then question answers are always welcome at the any time. Whenever you have a question, point me, and then we'll discuss about what that questions and whatever the answers that it comes into. So you can move it. So let's see why the build system. Okay, if you and you almost like the new guys, the new generation, maybe 2010 around. Okay, the little bit knows about the old Linux system and the Mac build system. It must have built the Linux driver. Okay, so it started somewhere into the Sun microsystem. Okay, and they were building the Solaris, and they were using a Mac build system. If you are working with the Linux, sometimes you need to compile the Linux drivers and Linux kernel, and they are more used with the Mac system, the Mac build system. So like you make, install, and make things. So in general, it has the goal, some kind of like action, and then and that action, it has various commands, sequential of command. Okay, so from that inspiration, Sun microsystem has first built the end. Okay, but this build system is not the main product. These are all the outsources and outcome of they were building something, and to build something they needed the tool and those are the third party or kind of like side products in terms of. Okay, so why they created Arc in early 2000 they were working of building servlets and JSPs, a very early specification, and for the proof of concept they gave a Tomcat. Everyone knows what is Tomcat. Okay, and to build the Tomcat source code, at that time there was no build system for a Java. People were doing the bash files and commands.
Yes.
Okay, Chelsea, on 2000 and even beyond that one. Okay, even I have worked with the command line with the servlet runner. If you anyone have heard of the servlet runner, at the very early days when there was initially they gave up those kind of technology to the public. So to build the Maven, build the Tomcat, they created the ant. And if you see the ant structure is very much similar to the Mac build. Okay, but here in the Mac they maintain everything in the plain text file. Here they gone through the XML based approach, and then in the XML based approach you create a target, and then under the target you run your sequential commands, the ant commands. Okay, and that's how they started building the Tomcat using an ant. Okay, in 2003 somewhere there was one more project which called Apache Turbine. It's probably absolute now, and it was solving the problem of rapid application building, the web framework. And to build those web framework, they were like doing lots of layered approach. Like they have APIs and the different projects, and the WARs are different projects, and the extension modules are in the different projects, like the small modules. And to build projects with such a clarity and the modular granularity, they started working parallel to the building the Maven. So Maven is also the side product of Apache Turbine. It's never intended to be a main product. Okay, and then here Sun Microsystem has handed over the Ant and Tomcat to the Apache. So these two maintained were Apache, where the Maven was incubation for around 2003-2004, and after the 2004 it became the main lead software on the Apache. And they were introducing around like Maven 2, and then from 2008 the birth of Maven 3, which we currently use Maven 3.8, something 3.8.6 and something, and the POM model 4. They were introduced in 2008 somewhere. Yeah, so we spoke about its side project of Apache Turbine, but Apache Turbine is already dead project, and Maven become the solid superhero. And it's a software build system. So what they came with the idea that there are two things. One, you need to build the software. So there is a sequence of commands that you want to execute, which is called a life cycle. Okay, and then to build the software, you need third-party libraries, dependencies. So they separated out two things. Okay, and now you see that there are dependency managed separately in the build systems, and now you have this life cycle. So this is what the concept they came into the system. Okay, and then you need to do a lot of things when you build it, and complex tasks and all the stuff as part of your build project. So they built something completely in the plugin base. So if you see the Maven, okay, Maven is everything is plugin. There is something called the Maven reactor, the core component. Okay, and then every code that you write, like Maven clean or Maven install, those are nothing, but those are actually the plugins are developed separately. Okay, but as a life cycle, they have somewhere the tightly bound. Okay, so we'll speak about that one. And then for the dependency management, the most important aspects, they introduce kind of like GAV coordinates. It's a group, artifact, and the version. So this is what the basis is. So whenever you call any dependencies, so you need to like org Spring framework. So that become a group, and then you have a Spring core. So that's become an artifact, and then now you tell me that exec 5.0. So that's the version. So that means that you are targeting the Spring framework's core libraries exec 5.0 release. Okay. So that means that pinpoints to the one of the library of multiple releases of a framework. So this is what they came with the idea GAV, and after this GAV, almost like all other build systems like Python and everyone has a similar concept to manage their libraries and to point the multiple versions when you work with. Okay, they introduced one more thing, which is fixed folder structure. Okay, so they ask you to maintain your source code in a particular fashion, in a particular folder structure, layered structure. So the plugin can easily find what it need to do with the configurations. Where are the source code? Where are the files? Your test cases are there. Okay, and can do a different work at the different layer. Okay, so this is what they introduce the folder structure, and then they introduce complete build lifecycle. Okay, so build life cycle is means like how you start, okay? Then what should be your first stage, okay? When you should be compile the code. After compilation, whether you should be a run test cases, you want to verify that everything is built. If everything is built, you need to verify and make sure that it's packaged well. And these all things are interdependent and goes in the one sequence. So this is what they introduce. And then every of those life cycle phases, you do something. Okay, either you do a one task or you do multiple tasks. Okay, so this is what they introduce the build life cycle, and then based on the build life cycle, it invokes the plugin, it downloads and finds the GAVs, put it on various class paths and wherever you define. Okay, and then it find the configuration from some folder structures. Okay, like the source code or the property files or packaging configurations, everything from here, okay, and then it produces the build. So this is what the Maven does, okay, and if you understand how these things function, okay, then you open lots of possibilities of doing crazy things just using Maven, okay. There are so many things there, and then there are so many plugin ecosystems everywhere now that you need to find the plugin, put it in your system, okay, and you can achieve almost everything. Like you can do a CI/CD pipeline, you can do automations, deployments, you can control the production environment, you can connect so many different systems with the help of the plugin. So this is what the main achievement that in the system, that if something is not available, you can write your own plugin, okay, but mostly you will not able to do, not needed to do it because tons of things are already developed. Okay, you just need to find it where those plugins that intended for your work, get the configuration, put it in your build system, and execute it. Okay, and we will speak about some of the plugin. I'll show the fully practical demo where how things works and how it looks like when it gets processed. Okay.
So how different is it from Gradle, another build system?
Gradle, it's started with the pure. Okay, it's not drastically different. Okay, internally it also invoke and get the base from the Maven repository. So Maven repository is the base.
Right.
Okay, GAV coordination is also there. Okay, here everything you write it in the XML configuration. Okay, and this XML configuration designed in somewhere 2008. If you see the Maven POM, it's a 4.0. Okay, POM structure, the XML file structure, and that 4.0 structure it started somewhere 2008, where they released the 3.0 Maven. And in this current situation, okay, that 4.0 is not enough. So there is already something is cooking in the Maven, which is called a 5.0 POM. Okay, so you will write the newer POM version. Okay, but it also has somewhere internally the backward compatibility of the 4.0. Because of the entire hundreds of thousands of projects are using 4.0 Maven structure. Okay, and this is what the Gradle is able to solve that one based on the configurations.
Yes.
Okay, but the debate principle is same. They have a phase. Every phase has light to some plugin. Okay, and internally that plugin invokes somewhere the Maven based source code. Okay, that finds the dependency from the Maven repository. But that build structure and build file, it looks a bit different. But the concept is exactly the same. They have dependency management, they have plugin management that you need to write it in the sequence. But it's more kind of a JSON looks file. Okay. Here, this is XML file, and this XML file is in the XML. The reason is that if you go to the older days, okay, there were XMLs everywhere. Okay, and the JSON was not there. JSON started in 10 and 15 and then after so like 12, where people were talking about the REST web services and those ones. So after maybe 2010 and all those stuff, JSON started getting picked up and people liked those much more. Okay, but the older days, if you go the older services, they will have the SOAP web services and everything is XML, and that's why the ad started with the XML. And then from the Maven is also maintaining in the XML format. So it's difficult to read it, but this is actual screenshot I cut from the Maven document, okay, online. And this is defined some of the folder structure that you need to understand. Like if you see the first one, that is SRC main Java. This is where your main Java code. Then you go, then the SRC main resources, SRC main filters. Okay. So resources basically you put your property files and those ones here. Java code goes to the Java folder, and they have like similar structure for the test here. Okay. So if you have like one package, okay, and one class file, and you want to exactly override that class file and do something where the class name is everything exactly the same, okay, but this specific to the test purpose, then you do that coding here and the test, okay. And so your test code and your production codes, it remains separate completely, okay. And even these things here in the test is not get packaged, okay, but it will just get executed. And then you can override the configuration from here to here for the test purpose. Similarly, from here you can override filters here. This is something interesting. If you like SRC or IT, probably you have not much seen that one. Okay, but this particular folder structure is intended when you create a plugin. Okay, so you creating a Maven plugin, and then you cannot just create a plugin. Okay, you also need to test it. That you use the plugin in the POM, okay, and then POM is working correctly with your plugin. So they have a separate folder structure here, SRC to IT, and you can see some of the Maven plugins on the GitHub. Probably almost all plugins are in the GitHub, okay, and these are like assembly, okay. So you put the assembly descriptor here, SRC site if you want to generate the websites here. And then some of like license file, notice file, readme file. So these are the basic folder structure, and this is advisable to use that one. Okay, if you want to do crazy, yes, you can change this one. Okay, but it's a crazy thought. Okay, we tried it and we are able to do it, but the outcome were not so much predictable because this is the notation, and the many of the ecosystem plugins expect that you follow the notations. Okay, so you can do something here, okay, but not drastically. Okay, outcome will be like not desired that you want to have that one. So it can mean that you follow this folder structure, okay, and then your ecosystem works very well. You don't need to be much worried about the weird exceptions and the weird thing. And this is the question comes in first, okay, when consider you have some old, very legacy software. And when you put the Mavenization over that one, okay, you will first thread and find that your source code is not in this format, folder structure. Okay, so you will have to relocate the source code in this folder structure. Okay, and your first thought that I don't want to like relocate the source code. Let me use my folder structure with the Maven build. Okay, so that dilemma will come everywhere where people do it. We were also faced that one, and it was hard to explain the management that we'll have to restructure the source code. We cannot use whatever existing there in the old fashion. Okay, and we tried it using existing source code. Then output was disaster. Okay, it was not very much predictable. So eventually we converted and refactored all source code libraries and folders into this fashion, and then everything works well. Yes, this is the classic example. Okay, this is the sample POM file. Okay, this is sample POM file for just one project. Okay, and then this is probably the smallest one. Okay, and some of the basic elements that you need here, and you need to understand those ones only. And then later we'll talk about what extra you can add here. Okay, so if you see the first slide, okay, this defines the model number 4. So this is what your POM structure is. Okay. Soon in a couple months or a year maybe we will see POM version 5. It's already available if you want to try it. Okay. But it's not yet released. But there are talks here. Most important thing is this group artifact and the version. Okay. So it's like com.rbsony.app. You need to define your artifact. Okay. You need to define the version. Okay. And the important thing is here the snapshot. When you write a code, okay, on a daily basis, your body need to be marked as a snapshot. Okay, and not the releases. And it's mandatory that you differentiate your version, okay, with the dash and snapshot. So this is your HO artifact ID, okay, 0.0.1, okay. But as you are developing the project, okay, it is not released yet. So all in development projects need to be marked as a snapshot, okay. And there is a separate arrangement to maintain the snapshot, okay, in compared to the release. So we'll speak it about when we talk about the repositories, okay. Then most important thing, this packaging, okay. There are a couple of type of packaging, okay. And then when you if you don't define packaging here, okay, like you just remove this line, then default packaging is jar, okay. If you change something, like okay, you change the var, okay, then this packaging type involves your life cycle. So there is a pre-built life cycle attached and associated with each and every packaging type. Okay, there is one more packaging type called a POM itself. Okay, so POM is just XML file and has very small life cycle. Okay, but if you do a jar, okay, then jar has a much bigger life cycle. Similarly, you can have a var, you can have R, and there are 6 and 7 options. Okay, and if you want to do a crazy here, okay, there is a provision that you can have your own packaging type. Okay, I'll show you an example where you find that one. Okay, if you want to go and then see, okay, how you can change this packaging type. Okay, this is the name and description, this visual data here. Okay. This is the property segments. This is a very important section. You can define lots of properties here. Okay, and many plugin and the plugin individual options come with the predefined properties. Okay, like if you are working with the software, okay, and you want to change your Maven compiler version, okay, if you don't do anything and just run the software, it will expect that JDK 6 probably it's a default one internally, okay, and your software will fail, okay, because probably you will not able to find a JDK 6 build anywhere else, okay. So you need to tell your compiler plugin that I am targeting the JDK 11 or JDK 4 or JDK 14 or JDK 17, okay. So this is not the actual location, okay. I'll show you how you do it, okay. But here you define your property with this predefined property name, okay, and the value, okay, and then it will impact your plugin's execution. Okay, so there are options like you can pass it from the command line, okay, then command line will be so big, okay. You can add that all property listed here, and then you can when the Maven start, it reads the property and then it correct and set the appropriate versions to the individual Maven plugin, okay, and then it start the execution. This section, though it is commented, okay, but this is called a dependency management structure, where your project needs the third-party libraries, and this is how you put your dependencies here. Okay, so here, for example, I am using JavaX Servlet, where JavaX Servlet API is my artifact, and I am targeting the 3.10 of the version. So this, when if it's not commented, when I run this one, it downloads this library from the Maven repo, Maven Central, if I will not have it locally on my local M2 folder, and then it will send it into my class path, and then it will execute the code. Okay, so this is a very basic structure, and then you do a lot more. There are a lot more sections, but it's not able to put it here. So we'll show you the complete demo. Yes. This is more practical example. Okay. This is an example of a form of a multi-module project. Okay. And most likely you will work on this kind of a project. Okay. Where you have like JPA artifacts are different, and then you have the services code are different, and then you have a web module in the product. Okay. And then you combine together and then produce your artifact. So most of the project will have this kind of structure. Okay, so the upper section is still the same. Okay, I just remove those XML configurations to make it shorter. Okay, if you see this three line here, okay, it's a Maven compiler source. Okay, and then I have used this Java version as the variable here, the dollar curly bracket. Okay, and then same variable goes to the Maven compiler target. Okay, what this means is that this is the properties of a Maven compiler plugin. And it tells that this software is required JDK 11 and the builds and everything will be done using a JDK 11 only. Okay, so this is how you can change the behavior of your underlying plugin and set some of the defaults. Okay, there are different ways of doing that one. The easiest way is you go to the plugin, you see the plugin properties from the goal section, and every property has some kind of like those kind of external property values. Okay, and then you define everything here in the property section, and then it invokes and it's apply those behavior. Like some will have a true, false, or some will have the numbers. Okay, so there are a long list, and every plugin has this mechanism to attack that behavior. Another important section, if you see here, the dependency management. Okay, on the previous slides, it was a dependency. Okay, but here it's a dependency management, and if you see these two things are extra added here. So what it does is, Maven has a concept of the build lifecycle as a separate, and the dependencies managed as a separate list. Okay, previously they were like all combined in the big list that you have a dependencies, and then on the same file you manage your lifecycle. Okay, and it was not good state because your lifecycle almost remains same. Once you start a project, okay, your build structure and the build flow, it's not getting changed so much over the time. But then what things will change is the dependencies. So that's why they separated out two things here, and they came. This is what this is example called the bill of material. Okay, Maven bill of material (BOM) in short. This is actually an entire Maven file and has all its of dependencies only, nothing else. Okay, and this is the Spring Boot example because like everyone loves Spring Boot, everyone code on the Spring Boot and nothing more than here. Okay, so you can get all those dependencies that your Spring Boot application need. Okay, and this file have all those versions defined, everything. It's kind of like very big list, and you can read that one. And then every third-party libraries like JSON, Fastly XMLs, and Commons, Hibernate, JPA, Web, everything is marked with a particular version. It's a very big long list. Okay, and at the end you see this section. These are the modules. Okay, these are the modules. Basically, this tells you that you have a sub-projects of this project, and the project name is JPA. And then there is a service project and there is a web project. And for this file, this is the parent file of a project. So it has a packaging type POM. Okay. So this is just does nothing, but it controls all these sub-modules, and it builds sequentially. When you just build this system as a Maven clean install. So I have an example of this one. We'll also see this one in the practical. And if you see this structure, okay. So this structure is service project. So here it's a service, the second one. And then when you go to the service folder, you see the POM, which looks like this one. And then it has a jar file as a packaging. And then it's a parent. Okay? So when you work with the parent and child project, this kind of multi-module, you need to define this GAV of the parent. Okay? As the parent here. So that's how these two are linked together. Okay? And when you add the dependencies, okay, like sub-modules, internal dependencies, like here you have a JPA, okay, and JPA it's required to run the services, okay. So when you compile the services code, that means your JPA code should be in the class path, okay. So this is how you do the internal dependencies. So the same project, but if you see this thing has changed here. Okay, I'm not defining the actual version, okay, what I need to do. So these are the internal, Maven has lots of internal properties to identify internal values. So this is called the project version. So what it does, okay, if you see here, there is no project version, okay, but there is a version here, and this is the project version, it will get it from here, because it's the only parent version that is defined. So you define the version here of a parent form, and throughout the project, okay, this version has to be consistent, okay, and if you have not this consistent ways of version managing, then it would start creating issues when you compile it, okay, because when you do compile, every time it creates a new build, okay, and then it install into your local M2 folder, okay. So when you have a snapshot, you will see tons of your builds are getting done, okay, and if you have not exactly tell that which version of libraries that I need to get it in the class path, sometimes you get the older versions of build in the class path. So defining the version is extremely important here. Okay, if you mess it around, then it will also impact a lot at the release process. So we will go through the release process and then we'll show how this gets impacted. Okay, but this is the ideal structure of your multi-module parent form, and then you have your child form, and then you can have n number of projects. Okay, and then every project will have this kind of sub-modules project files. Okay, and the most important thing that you need to make sure that if you have so many projects here as a child, that should not have circular dependencies. Okay, so like services need a JPA. Okay, and then you cannot add the JPS to the services. Okay, it has to be on the tree and the state structure. Okay, if we will have a circular dependencies, it will not get compiled. So this is what, when you arrange multi-module project, you need to make sure that my utils and those base code goes first. Okay, and then the second, and then the third, and then the fourth, and everything get built, and then I want to add it to the web. And this is what my final output is. Okay, if you have circular dependencies, you will go nuts, and then you will not be able to find it. There will be lots of refactoring about the source code and all the stuff. Yes. I have not created this image. It is downloaded from the Google. Someone created it, but it suits very well. Okay. If you see the Maven, okay, and the Maven has a life cycle. Okay. So first important thing is packaging. So we see the form, we see the jar. There are var, r, bar, EJB, EJB3, and couple of more are predefined packaging types. Okay. Then you have phases. So when you have a packaging type, you select the packaging type, okay, and then based on your packaging type, it invokes the phases. Phases is basically a life cycle, how the sequence it processes, and then every phase is associated with some of the default plugins. Okay, so if you see the Maven clean is a plugin. Install is the plugin, okay. There is nothing in the Maven, okay. But in the Maven, there are plugins have a short names, okay. Actually, there is nothing like a clean, but it's a org Maven clean plugin, okay. So it's a bit longer, but it's not easy to type this the entire GAV and then the bold in the command line. So they maintain some kind of internal configuration within the Maven. Okay. So if your plugin is so popular, okay, then it has a short name, an universal short name. Those two plugins cannot have the similar short name. Okay. So I'll also how that is done. Okay. So when you have a plugin, you have a goals. So plugin will provide you the one or n number of goals here. Okay. And then your projects need the dependencies. So this is what you get the class path libraries here from for your requirement project development. And then you have something called profiles. This is very important and this is very useful thing because there are lifecycle systems does lots of stuff. Okay. and then based on certain conditions, you don't want to run entire full blown life cycle at one place. Okay, like you are a developer. Okay, then I don't want to create my Docker build on your DevOps. Okay, whenever you compile the code, as well as I don't want to run my code statistics and the PMDs and find bugs and code verification modules on the developer box. Okay, because I want to make sure the developer build the software very fast. Okay, if I run this entire life cycle on each and every developer box, then your the coding cycle will be very lengthy. Sometimes the complicated projects take maybe minutes, or if you build a Docker, then it goes very time consuming. Okay, so those kind of life cycle you can make it conditional. Okay, and then you combine those plugins together and create the profiles. Okay, and this profile you can invoke based on your requirement. Okay, or based on the automations, or based on some of the conditions like build systems or something, or if you want to explicitly run, then you can define it in the command line. Okay, so you have so many things, but based on the situation, you want to run very small build cycle, okay, or full blown check, and you can do it at the various times. Okay, and then once you build something, you need to distribute your project artifact. Okay, so it has a distribution management. So these are the core structure, and these all are linked to each other. Okay, so if you see this image, okay, it's a bit blurry. You can get it the exact one from the Google. It's from the Google image some website. Okay, this one is the default life cycle. Okay, then this one is for the clean. Okay, when you run a Maven clean, okay, then it has a pre-clean, clean, and the post-clean. It just does 3 actions. This is the life cycle of the Maven site. Okay, if you go to any Maven project, every Maven project has similar website. Okay, you file almost exactly same color combination and same folder structures and everything, like left side menu, and then all complete same menu options and everything. So that is built using Maven site, and it also has the pre-site, site, and then other phases. Okay, and then this is the default life cycle. Okay, so what it does, it's a call of validate, and then it goes with the resources, go with the compiler plugin. This is the install plugin. This is the packaging, verification, install, and this is probably a test, and this is deploy. Okay, and if you see this, all those pipeline here. Okay, like compiler plugin goes to the Maven compiler. It's a compile to compile call, and the plugin deployed here is a Maven compiler. So each and every life cycle goal is associated with the sum of the plugin, and you are free to go to the check the plugin. Okay, and if you want to do crazy, you can child the project, you can code it, you can alter the behavior. Okay, and here there were like these are the phases which you cannot configure it outside. Okay, you need to configure the Maven file, and then you invoke this one. So this is the life cycle. We will show exact the practical to show more from the coding point of view. But if you see that, like every more than everything in a Maven is associated with some of the internal plugins, and there is only plugin and there is nothing else here. So if you want to do something, find the plugin. If there are no plugins, you develop your own plugin. Okay, and if you don't want to develop the plugin, then there are shortcuts. I'll show you. I have done a couple of those ones that by doing some coding, help up some of the existing Maven plugin. Okay, and you can do a lot more crazy thing. Any question on this one? Because very crucial portion here. You understand this behavior well, okay, the execution, then you can do everything with the Maven. This is the heart. It's the same, but it's a much bigger size, so you can at least see it properly? Yeah. So this is what the packaging is, and this the complete list here. Okay. So it supports EJB, EJB3, jar, R, par, jar, var, POM. There is a Maven plugin packaging, and if you see the Jenkins, again, if you have downloaded Jenkins plugin, okay, the plugin comes with the extension of HPR, okay, and there is nothing but it's again customized packaging type for the Maven. If you have anyone have developed any of the Jenkins plugin or even done the Hello World, okay, then Jenkins has its own build structure and complete folder structures and everything that customized to suit with the Jenkins plugin building. And this is what they develop entire ecosystem and then given them HPI. Okay, so if you download any Jenkins source code from the GitHub, okay, the first difference that you see, that is HPI. This is not the standard, it is exactly the customization that they have done for a Jenkins plugin builder. Okay, so if you want to do crazy, you are free to build your own packaging type. Okay, and then you define what you need to do and how the lifecycle will work with your packaging type. Okay, if you define nothing, okay, then by default it invokes the Maven jar. Okay, if you just take the packaging and remove that line, then it would invoke the Maven jar, and the output that it generates is a jar file. Okay, and then when you switch to the packaging type, okay, it changes the lifecycle phases that it invoked. Okay, so what you get is in the sequence of process for a jar is not exactly what you get for the POM. Okay, so this is what you need to understand, that what you exactly building it. Okay, and then also when you change the packaging type, every packaging type itself is a plugin here. Okay, so if you build Maven jar plugin, jar packaging type, so by default this lifecycle will map jar plugin. There is a plugin called Maven jar plugin. Okay, and there is a goal jar. Okay, and that goal will include get executed. If you change it to the var plugin, okay, and make a web archive, then at the install phase, after the compilation and the packaging, it will invoke the Maven var plugin var goal. Okay, so this is how these things are mapped. Okay.
So let's say if I want to build an RPM or dev package as a custom package,
yes.
Then I'll have to rewrite maybe I have to write plugin as well for that.
Not exactly the RPM or a dev package. Okay, that means you are talking about something a non-Java application. Okay, so something I have not mentioned, but this Maven build system is not only integrated for a Java application. Okay, it has something advanced use cases, and when it calls the Maven tooling. Okay, so consider you building a software. Okay, kind of software that is more specific towards your integrated environment. Okay, like there is a explicitly something that only runs on the Windows, and you want to make a Windows build. Similarly, you have something that wants to run on the Linux, okay, and then some of the extreme version of Unix, and you want to do some compilation there. Okay. Then there is hidden configuration. It's not hidden, but it's an advanced configuration I call. That called a Maven tooling. In this Maven tooling, you define your environment, your executions of a compiler. So by this build system, Maven, you can compile your C++ code, you can build your Windows .NET environment and produce various other artifacts. Okay, and the behavior that you see here, okay, that everything can be altered. Okay, this is more like kind of the straightforward scenarios.
Yeah.
Where most people think it's the Java building process.
Yeah.
But use cases go beyond that one.
Right.
You configure the entire Maven tooling shell, okay, and then the same code base you have kind of like, suppose you have a distributed setup of Jenkins, okay, and then you have an agent run for the Linux, and then you have an agent exclusively built for the Windows system, okay. and then based on the environment, okay, you can invoke the different plugins, different profiles, and different tooling automatically, okay, and then every node will build the same software but produce the different artifact.
Right.
Okay, so you can go with the RPM, you can bundle with the ISO file, okay, with your source code, everything. And so there are a lot advanced use cases.
Yeah.
Okay, but those are very common cases.
Sure.
You need to explicitly first learn the basic and learn the plugin. Okay, and then once you know okay how this system works, you can build one software for like you can build RPM, Dev, Microsoft EXEs, then Java file, jar file, var file, everything in a one shot.
Okay.
Okay, and then if you have a distributed systems, it has a environment detection ways. Okay, and then just one sequence, but if you are running on the Windows and have something to satisfy the requirement, okay, and then based on certain requirement you can activate certain profile and deactivate certain profile, okay, and do that one. I'll show you because that is the very important use case, and we do it everywhere. This is also the screenshot that I cut here from Maven documentation. Okay, what it shows that Maven has a life cycle and phases. Okay, so this is the list of phases here. Okay, and then every phases are associated with the individual plugin and the individual goal. Okay, so these are pre-configured right away within the Maven source code. Okay, some of the things you can change it. Okay, but if you see there are phases named with the pre, post, and process. You cannot invoke that from the outside, from the command line. Okay, you can change and associate certain plugin executions for those phases individually. Okay, I'll show what that means. Okay, but these things you can compile, like you can Maven compile, and these things can be executed individually as a command line. And this is the default lifecycle of EJB, jar, par, rar, and var. So if you have a package like this one, okay, then this is the sequence it get invoked automatically, and these are the respective plugins, and every plugin has a configuration here. So if you want to change something at the resource level, okay, then you can customize this section, you can customize your compiler behavior, you can customize your source phase, like you want to skip the test cases build or not. There are whole sets of individual configurations, even like this is the deploy plugin, so you can define where to deploy. You want to upload the artifact to the S3 bucket, you want to upload artifact to the some Nexus repository, you want to upload to the GitHub repository, okay, or you want to like do where your artifact goes, you can define that configuration here. So this is all the default life cycle, and then phase mapping. You can go ahead. Yes, this is how exactly it works. This is the code snippet exactly from the Maven source code. Okay, you can find this a file on the GitHub on the Maven core file, core body, Maven core library. So what? And this is the life cycle of a Maven var. So there is a var provider file .java, and it has the bindings. Okay, so this is gives you much more clarity what it does. That when a call, this is from Maven 3.8.6 or something, the release, the latest source code. And when you call an install, Maven install, okay, it does nothing but it download ORG Apache Maven plugin, Maven install plugin, 3.0.0 M1 release, and the install plugin get executed here. Okay. The most important thing here that whenever you add any plugin to your build system, okay, you must add the exact version number here. Okay. The thing is, this recently happened. There was a release on the Spring Boot and the Spring Boot Maven plugin, maybe last month or somewhere. Okay, and that somewhere it's broke the backward compatibility. Okay, and then they released it. We have the repo systems in our build system associated, but it was not published to the Maven Center for the public. It was within the Spring repository, okay, and that triggered the whole build system failure, okay, because some of the developer has not mentioned the which exact plugin that they need to invoke, okay, and so if you don't enter plugin number exactly the version number, then by default it invokes the latest version. Okay, so currently it's the M1. If there is an M2 released, okay, and this version is not mentioned, okay, on the execution time, it will again go to the repository. It will find, okay, what is the latest version. It says the M2 is the latest version. M2 is not compatible with your older behavior, okay, and then unexpectedly your build will get failed. So this is what recently happened with the Spring Boot release. I think Spring Boot release has a Spring 3 somewhere, and then that was breaking the backward compatibility. So this is what the case, and that's why even within the Maven source code, every release, this is the Maven class file copy, and they have explicit version mentioned here. Okay, so your behavior will be completely predictable everywhere. Okay, not based on something runtime. Someone has released something. Okay, you don't know what it got pulled it here, and then yesterday it was working in night, and today everything is get fall apart. Okay, so this is what exactly you need to make sure you have precise version everywhere. Okay, and then you don't get in such kind of the problem. And this is, you can see all files. You can go to this source code, and then you will see the mapping of POM, mapping of clean, side, jar, var, r, and even you go to the Jenkins build system, and Jenkins has similar mapping for the HBI plugins.
So I have one maybe slightly more ways. Two things probably. One is like nowadays CloudCommit, at least in AWS, they introduce ARM-based processing. They will talk about that. So is it possible like to cross-compile, or it is better to run build this Maven on Graviton only, or what is there any difference into that or not?
No, this is the build system. Okay, it does nothing. Okay, this is kind of like your command execution chain. Okay, but it depends when consider you running a Java code, okay, or you consider using a Maven build system, okay, but you want to do the C++ compilation. Okay, C++ compilation is more kind of like your environment specific to topic. It's not that much interoperability. If you have a GCI lib is different from the Red Hat and the Debian, okay, then you can change here Maven tooling, okay, and you run this Maven build system using JDK 8, okay, because this is a Java code, so you definitely need the JDK to execute this build system. But when it starts compiling, okay, it forks the process, okay, from the Maven compiler plugin, okay, then it goes what are your tool chain, okay, associated, and then based on the tool chain, okay, it can produce your native artifacts based on what you want to do it. Okay, so you have something explicitly that works over the ARM processes, okay, and then you have something native, then definitely you can even create the profile, okay, in this profile, you can section by section change the behavior, okay, and then based on you select that my Jenkins node or my build system is running over the ARM system, okay, and then my compiler should produce the output of the ARM compatible libraries, but the same build system is running over the Windows system, okay, so I can tweak the profile, okay, and then it will pick the tooling that is associated with the Windows, and then my source code will get compiled over the Windows system, okay, and then simultaneously you can produce the both the artifacts. So internally it's so flexible, okay, and then you can tweak the behavior, you can change the compilers, you can even build the .NET configuration files, you can produce EXEC, whole sets of things here. But those are like very advanced use cases, and you need a lot of internal changes, like you need to understand Maven compiler, tooling files, tooling configurations, then detecting your environment, and then entering the profile. So you can change the same build system but different configurations. Okay, so it's definitely possible. Okay, consider this is your build system. Okay, but it's not associated with your internet output. Okay, you need to plug here. Okay, and this helps you to process one life cycle of a build system. So that's why they have detached those things. Okay, if in Infodesk, okay, we set this one maybe a decade ago, and then we set this one for JDK 8. So entire Maven execution is done over just JDK 8 one system and nothing upgraded. But from the same system, we built for JDK 11 code. The same system built JDK 17 code, 14 code, and open JDK and Corota, and whatever JDK that we define, okay, it picks the JDK and produces the output of that completely. So it's completely detached here. Okay, how you execute and then your compiler and all sorts of requirements are separately maintained, and that is what Maven doing.
So I think it is dependent on the version of Java or JDK which you are running. Because why I am asking this? Because like I built something, a WAR file, which was an x86-64 architecture, not an ARM processor. Right? When I try to, once the artifact WAR was created, I tried to run it on ARM. It did not run because the hardware architecture was different.
No, it's not for Java. See, Java, the bytecode is same.
Right.
Okay. It's the JDK that you need to deploy. That is for the ARM, because the Java command, okay, it has the native dependencies of the operating system like CG leaves and all those stuff together. Okay, and those like your IO socket and those things come from the native implementation.
Right.
Okay, and those native implementations are specific to your operating system. Okay, and your architecture. So if you download the Java, then you need to make sure that the JDK is compatible to your the internet environment and not the compiled code. Okay, if you compile to the JDK 11, then whenever you install the JDK 11, okay, and if it has a libraries associated with that one, it would run it. Okay, only things that started creating a problem because Oracle gave up the JDK, okay, and then from the open JDK, they separated out modules like. The JetSuite got out, and then they were like rename of the packages because of Jakarta and the licensing issues. Okay, if you are upgrading it, then those are the difficulties. Like if you have something built over the JDK 8, okay, JDK had like JetSuite and all those components comes in between together like as the package.
Java effects and all this.
Yes, but for JDK 11 or the 14 or 17, those are the external libraries now. So those things that you need to manage. Okay, but the operating system specific things that goes with the Java, okay, and not with the compiled code. The bytecode is the same. You need the dependencies. Dependency is compatible with your library OS, and then it get executed here. Yes. So we spoke about the build system and the lifecycle. Okay, how it get executed. Now, you understand the dependency management because this is how your source code will get the dependent Java files everywhere. And there are two kinds of dependencies. This you need to understand very well because this creates a lot of problem. Okay, if you add any dependency directly to the Maven, okay, then default it call at the compile state. Okay, if you don't provide anything, there are different scopes of how the dependency get associated and act in the build system. Okay, but there are things called transitive dependencies. Okay, so if you add dependency like Spring Boot Start, okay, so that is just one dependency, but actually it is not the one. Okay, in the behind it goes 2 or 3 layers of other dependencies and bring total over 11 or 13 dependencies in your project. Okay, so you see this one dependency directly, and that is called direct dependencies. But whatever things that get put from this startup project, okay, that are called transitive dependencies, and this is the create the most of the problem because sometimes you don't know what is getting built and what is getting put into your class path. Okay, because you don't know how the dependencies are built. Okay, and sometimes you don't need a JDK, the famous one, Log4j. Okay, your system works over the log back. Okay, but you added some of the dependencies, and that dependencies also bring the log4j code into your system. Okay, so when you have a final output, okay, those things will get packaged. Okay, and then you get nuts. I don't use this log4j. I use logback. So why this comes in here? Okay, so that comes from the transitive dependencies. And every dependencies have a scope. Okay, so if you define nothing, just add the dependencies, GAV.
Excuse me.
Yeah.
So once it generates the jar file, that jar file can be used in other projects, right?
Yes.
So what if I have written a form.xml file that contains certain dependencies like faster kind of Jackson maybe. And the same so I have grouped that, I created a jar of it, I am using it in another project, and I also have external dependencies with the same name of but with a different version. Would it conflict or would give error, or it will override the existing dependency?
Now, say this is a very typical use case, and it happens everywhere. Okay, consider you use this on Spring Body, okay, Spring Web, okay, a Spring Web starter, and if you add a Spring Web starter, it comes with the faster XML libraries, okay, because it do the JSON bindings and all this stuff. You can add the faster XML by yourself also as dependencies, but when it processes the Maven, okay, it checks what are the precedents of those libraries, as well as what are the latest version of libraries, okay, and what level it declared, okay, and then it finally find that what version it has to pick, okay, and then only that version will get bundled. But it goes with the G and A, okay, the dependencies group, okay, and the artifact A, okay. If that match, then for the particular version which it has to pick, okay, it has some weird things, okay, based on where it's declared, how it declared, which one is the latest, okay, and based on that, then it produces the output. But there will be just one library, okay, but the behavior will be a bit different. Okay? Sometimes you get the older get packed, sometimes you get the newer well get packed. Okay.
So is there any way like we can identify it is taking the is there any way we can like control over that dependency?
Exclude.
Yes, there is a way. We will speak it. I have a demo for that one. Okay, and there are ways that you can detect it. You can print entire dependency libraries. Okay, a tree. So it shows you that you have a Maven starter as a one dependency, and from the Maven starter, how many sub-dependencies, and how many sub-dependencies, like as it still goes, okay? And you can see that what are the transitive dependencies. See, your problem is exactly that happens with the transitive dependencies, okay? Directly you added it, okay? But when you go with the transitive dependencies, this is an error-prone system, okay? If you don't inspect at the full depth, okay, likely you're going to have issues, okay? And if it's backward compatible and minor upgrades are there, then it's fine. But if you are exactly targeting some version, okay, because of the bug fixes that you want to intend to get in your system, and if you have two different versions are there, you might get bug fixed version, the latest one, or it get override. It happens to us, okay. Currently, what we are doing is we're doing lots of dependency cleanup, okay, and we have lots of vulnerabilities, okay. This all open source project are fully buggy, okay. No one produce good quality code, not me, not you, okay, or not the Mark Zuckerberg or the Bill Gates or Linus Torvalds, or no one produce good quality code. Everywhere there is bugs, okay, and then bugs are get exploited, and then it got a vulnerabilities, okay, like Log4j, okay, or the Spring shell, okay. There was a Nginx shell, there was a bug in the recently with the Postgres JDBC driver, okay. So everything is buggy, and then they get fixed. So you need to exactly make sure that what version that you bundle, and this is what the direct dependencies and transitive dependencies inspection that helps you. I'll show that ways.
So I think while mentioning the transitive dependency, we can exclude particular jar file, right?
Yes, you can exclude it explicitly. You want to do it,
Yeah.
okay? But there are lots of other ways way you tweak it. Okay, and one way is definitely you can exclude that. Okay, I don't need these libraries. I explicitly edit from my own direct dependencies. So that is also one way. If we speak about the dependency scope, okay, it goes compile. It's a default one. Okay, so when you have a compile, that means it added to your class path. Okay, when you build the var file, this compile library will be get copied to the var lib. Okay, the folder of your var file. So that is compiled. The provided means it is needed in the class path for the compilation, but those libraries are provided to your intended deployment container. Okay, like servlet specification. Okay, or the JSU specification. So if you start a Tomcat has those libraries. Okay, you don't need it extra. So you can, but when you compile it, because of your code is using the servlet, you need the servlet specification library. Okay, but for a deployment you don't need because your container is provided. So that is called a provided. The runtime which is available, then there is a test scope which explicitly needed at the test cases level. You don't need it. There is system that means it doesn't download. Okay, it just assumes that this library will be available always. And even whatever you define with the system scope, it will not go and check from the Maven repository at all. Okay, and there is an import which is the last one. Basically, it doesn't do anything, but it helps to import whole sets of libraries from your dependency management form. Okay, and this is what in my first example I showed the Spring Boot Maven dependencies and imported as the import. So that particular one file, okay, is the list of hundreds of libraries. Okay, and then from hundreds of managed libraries, I put it into my build system, and then from the individual, I use it. Okay, that means like I will not get those hundreds into my class path. Okay, but the version can be managed and controlled at the one side. Okay, and then when I add to the dependencies, I do not need to add the version. Okay, I just can skip that one, but the version will be controlled from the dependency management BOM, which is added as the import scope. Okay, so this is what you should use that one. That if you have n numbers of libraries, create your BOM file. Okay, and then refer the libraries from your BOM file. Okay, so your version will be tightly controlled in your set. Okay, and not like loosely, and you need to define to the each and every project. So just define it to one company level BOM. Okay, and then use that BOM to the across the all project, and the all project will have exit title dependency control. See, this is what the bill of material that goes with the import section. Okay, that means we have a collection of dependencies. Okay, and this is one of the best way to manage dependencies across the different products. Okay, and that's why if you see the Spring gives you the BOM. Okay, either you use a Spring as a parent. Okay, or you use the same thing as the import BOM, and they have a Spring Boot and all the certified or the verified libraries goes across the Spring Boot ecosystem. So that's why they give a BOM file. You just use that BOM file. That means that those all third-party libraries like Jackson's, Binding, Commons, and whatsoever are verified with the Spring Boot. So you don't get unexpected results. And this is how they manage the dependencies with the bill of material. In short, they call a BOM. This is the most important section. Okay, this is called a profile. What does profile mean? Profile is it's a set of a life cycle. Okay, and so consider you have an entire BOM file. Okay, you overrided 2 plugins. Okay, but for the different section, you can again override the same plugin. Okay, in name of the profile, and then you can invoke that profile. So when Maven start building it, it see that you have invoked and activated one profile. So whatever extra life cycle that you added, even that profile, it will get appended to the main life cycle. Okay, and it will get executed. The ideal use case for this one is like you have a source code and you want to run a PME and find bug. Okay, but you don't want to run PME and find bug on your source code every day. Okay, every compilation, it takes time. Okay, so you add into the life cycle. Okay, in your build system, but you add as a profile that this is my dev profile, okay, or my code check profile, okay, and then command line, whenever you want to just verify your code, okay, maven clean install space -p, and then give this profile name, and then maven say, okay, yeah, you also want to have this profile activated, and then whatever is written in that profile will get invoked, okay, and based on that you will have a life cycle. So conditionally, you can manually invoke, you can invoke based on the certain environment variables, the command line, okay, and there are lots of other activation rules that you can put there, okay, and based on those activation rules are satisfied, it gets invoked. So this is what the profile, okay, can be activated on demand automatically. This is help you to modularize your build process. So if you have extremely lengthy process, okay, chop it to the individual profile and make sure that the basic ones get run always. Then extra checks, extra building, extra that get profile, and then based on different areas, like on the build system, you run the full profile. Okay, you want to release it, you make extra goals there, and you want to invoke some of the dependencies management and some other stuff at the different conditions. So this is what modularize your entire Maven build process. Okay. You can define the profile per project. So when you have a POM can have a profile. I'll show you a working profile, how it can help you. At user level, you can add it to the settings file. There is a setting file in the M2 folder. You can add the profile and invoke from there one. Again, there is a global setup profile which goes to Maven home, conf and settings. Okay. Generally, we don't do much. You do sometime here. Okay. This is kind of like something very general configurations across the environment. Okay. And this is what you do mostly, which are specific to your project. So this is the profile. I'll also complete a full working demo for that one.
So what takes precedence? If I com.xml settings, .xml user home.
It combines everything.
So like I have two configuration in both the file, com and settings.
It combines the build life cycles.
Okay.
Yeah, and then if you have the similar plugins, okay, then it also override it. Okay.
Yeah. So
Start from here, here, and here.
okay.
But generally, I think no one knows about that you can write something at the Maven level,
Yeah.
because this affects across your Maven system. Okay. This also affects to the Maven, but it affects to the individual user.
Mhm.
Okay. So on the one system, I'll have my own M2. Okay. And you have the same logging, then you will have your own M2.
Yeah.
So it goes based on the user. Okay. And this is what tied with the project. And most of the profiles that people edit as a project level. Okay, don't alter it, you do it here, M2, mostly like if you want to provide the partials, okay, some kind of like distribution management, okay, which is like very constant and very stable. Once you do it, okay, no one gonna change it, okay. So those kind of thing that goes to the M2 settings and here, okay, but what you do with the build system, your build execution, that goes here, because those are individual project management stuff. It's not generalized. Okay, your A project will have different needs and B project has a different need. Okay, but both the project will go to your one central Maven repository. So that central Maven repository you put it here. Okay, and then the credentials for that Maven repository goes here. Okay, but project needs A and project needs B, then you put it here and then you execute it. The most beautiful concept that Maven came with the repositories. Okay, every artifact that you generate, okay, has to store somewhere. So if you run on your local system, then it goes with your local user folder. Then there is a hidden folder .m2, and then there is a repository folder, and then it goes with a layered approach. Okay, they call a Maven layout 2, the repository layout 2. They call where your artifact organized with the GAV. The group will have like POM, RV, Sonic, and the demo. So it creates 3 layers of folder. It will create a folder of POM, under the POM it will create a RV, Sonic, then under it will create another package folder. So like whatever dots are there in the package will be converted into the folder, and then from the folder it starts with your artifact name, and then from the artifact name it goes to your version, and then from the version it's put your actual artifact respect to the version. Okay. I'll show you. I have everything with that. Artifact are categorized as snapshots and the releases. These two are very important because when you do a coding, your project will be on the snapshot level, and the snapshot will get recycled. Okay, every time you build it. Okay, and then when you pull from the repository, it gives you the latest snapshot always. Okay, it will not give you the older snapshot as a dependencies. It maintains it until you release it. Okay, but when you fetch it, it will give you the latest one. It stores the snapshot with your actual release time. Okay, the YY, DD precise to the second level, and then some random level like -1, -2, -3, -4. This is how the snapshot maintained internally. Okay, but when you release the process, okay, as a part of the release process, the snapshot word need to be removed. So there is an automated process that it does. I'll show you that entire end-to-end demo. But the snapshot process make the word is get removed. Then you get the final artifact version, okay, like 1.0.0, and then it create the build with that artifact version, then store it, and the repository, okay, like the repository, what it does, like when you upload it to the Nexus or the Artifactory, it checks that you have released this software. Okay, then if there are older versions are remain in the snapshot repository, it would remove it. Okay, and the reason of this cleanup is that it has to manage the space. Okay, if you produce 100,000 of artifacts and every artifact is 10 MB, 10 MB, 50 MB, 100 MB, okay, then your disk space will get full like this. Okay, and then you will run out of disk space. So for that one, when you release it, the snapshot gone. Okay, now after that one, you just need to make sure you point to the releases. And many of you have seen that this artifact is gone. I am not able to get that one. Okay, if you have some dependencies. The reason, if it is released, then this like Sonatype Nexus or Artifactory or those prominent product would remove it. We'll speak about the CodeArtifact. I'll introduce where it different here with the AWS in the next slides. Okay. When you run the Maven, okay, it checks if there is a local M2 folder. If not, it create it with the empty folder structure. Okay, and then there is a central repo. They call a Maven Central. Okay, it goes to this URL and start fetching all dependencies that it need. And Maven is very small software. Okay, and then it has passing of the form. Okay, and then configuration where to fetch the dependencies. Okay, so it checks every time if the dependencies are available to the M2 folder or not. It see what are your software proxy configurations, dependency management configurations, remote repositories are there. Okay, if there is nothing is configured here locally, override, then by default it goes to here. So this is the by default settings. Okay, you can override this one and you can make sure that all your repository download does not go to the Maven Central, but it always bypass one of your proxy at system level. Okay, and these are the basic samples. Most popular JFrog Artifactory, Sonatype Nexus OS. Those are the prominent ones. They also support various other like Pi repositories and NVMs and all those stuff together. Okay, AWS provided the CodeArtifact as the Maven and Pi and all those repositories, and we'll see for the next section. And this is the hello world, the most important. Once you do this hello world, you can definitely add in your resume that you know Maven. Okay, so let's do the hello world. I'll show you how that looks like. No, important. Okay. આમાં થાય ને પ્લસ પ્લસ
Preferences manager.
બહુ નાનું છે
Preferences
go to preferences
Preferences manager.
Font मोटा सा है, control shift plus plus
Shift plus plus.
control
Control
shift
shift
plus
plus.
control shift
control shift plus plus ठीक है
ના આમાં નથી
control shift plus में पहले plus करा बाजू
હા
That's it.
હા ગુડ ગુડ થેન્ક યુ
પીલામાં પણ થશે પીલા ટર્મિનલ પર તમારે કરેલું
આમાં control shift okay this is visible yeah. Okay. So I have one sample file. Okay, just let me show you the sample file look like. Okay, આમાં થતું હશે
control
preference
control
ના બધું થયું same જ. Okay, let me this is close. Okay, and this is a close. So this is just a simple file. Okay, it has nothing here. It has a jar file demo, okay, and then there are no dependencies and nothing here. Okay, even I remove this one. Okay,
those who cannot see come in the front.
yeah, you can come in front, yeah.
A lot of space.
So if you see this one, okay, I have execute Maven clean and the install. Oh yeah, that's very good. Okay, in this one, it executes the first Maven clean plugin, then it generates the resources, then it calls the compilation. I have no source code here. Okay, it just plain file. Then it start to see the test resources, then test compile, then test. There is nothing there. Then it made the jar file here because the packaging type is a jar. Okay, then it installed. If you see this one, okay, it generate the jar file and then copy here, install it. Okay, so this is my folder where I am coding. Okay, this is the coding location. To the home. This is my the M2, then repository, then this is form, RB app. So these three become a GAV, then this become my artifact, then this become the snapshot because I'm on the snapshot version, I'm doing a programming. Then it made a name, this is my artifact name, then this is the version snapshot, and this is the packaging. So this is how it organized my artifact into my local, okay, and then when I do a deployment, it takes this artifact and upload to my remote repository. Okay, we'll show that one how it looks like when it goes to the remote repository. And when you build the system, okay, it also copy your POM file, okay, to your repository. The reason is that now if you add this artifact to this some other project as a dependencies, okay, then first it fetch the POM file, download the POM file, and from the POM file it sees that how many other dependencies that it has to fetch, okay, and then it manage and then also pull the jar file together. So artifact upload the POM jar file, and then if you have distribution managed, then it also upload the distribution and do it. So this is the jar file, okay. Let's do it crazy here. So again we are in the code, okay, and let's remove this one. Okay, and this whole section is commented out. So now this file doesn't have any packaging. Okay, just created, everything is commented out here. Okay, and the same thing. Okay, if you call the same goal here. exactly it called again the Maven jar plugin. Okay, so this is what the associated with your jar packaging. Okay, and everything is same, but let uncomment this one. Okay, let me remove this one. This is useless. We don't need it. Okay, and then we made it a POM here. Okay, nothing changed. We are come on the terminal. We run it. See what happened? What is gone?
Packaging type.
Say resources, compiler, this surfaces, everything is gone. Okay. Now even this Maven jar plugin is gone. Okay. So this is how when you change your packaging type, it invokes the different life cycle for each packaging, and then it tweaks the behavior. Okay. Now if you put it here var, similar. Okay. And for a var, you need to make some arrangement there, else it will start filling. Okay. So I made a var. Okay. I set the compiler that this var file is a servlet specification 3 and the newer, and as per the servlet specification 3 and the newer, a var file doesn't need a web.xml. If you go to the older dependencies, you need explicit web.xml. Okay, but now I am on the latest servlet specification. Okay, I don't need a web.xml. Okay, so I need to tell the Maven var plugin that this is optional. Okay, so this particular property added here, it's tell the var plugin that please don't go and don't fail my build because my code doesn't have web.xml here. Okay, and to satisfy that dependencies, I need to explicitly tell that my servlet dependency is 3x or beyond. Okay, so let's come here and then run again. Okay, so if you see these things are same. Okay, you have run the clean, so you executed the clean, then it started the compiler, test, resources, but yet it invoked the var plugin. Okay, I have not invoked the var plugin. It invoked because of my packaging type is the var here. Okay, then it start complaining that this is the snapshot app demo, packaging the web app. Okay, and if you see, it's now building the var file here. Okay, and then again the deployment it's the same. It copy that var file into my local M2 folder. So this is how you change your packaging. Okay, and then the underlying behavior and the output and the entire system will get changed. Okay, and similarly, what Jenkins have done that they have added to the HPI build system, the packaging system, and they have tweaked the entire the ecosystem of the Maven process. Okay, so they can make the Jenkins plugin development smooth and then fit with the requirement. So you can go to that extent and you can do that one. Okay, if you don't do this. Changing a packaging type will change the behavior. Okay, we spoke something about a Maven clean plugin. Okay, and then there are goals here. So now I am enabling one plugin here. Okay. So what I have done here, this is a Maven end plugin. Okay, so this execute the end row end command, okay, as a part of a Maven build, okay, and then in this section, in this target, you can write free from end configurations, entire end command, and copy, delete, RM, and entire end execution, okay, and then you can do something which is not available right away with your Maven build system. Okay, the plugin has a very strict life cycle, like the plugin and then plugin goal. Okay, and then goal does something in a sequence. But if you have something which doesn't fit to your any plugin life cycle, there are no plugin, then what's need to do? So you put the end file, end is a free from configuration. Okay, and then do entire your build sequence in the end. Okay, and at the end attach your artifact that generated from the end sequence. Okay, to the Maven, and then Maven will handle the rest of the artifact processes. And one more thing here, if you see this one. Okay, let me together put it here, this cut here and put. So add plugin has a one goal which is called a run, which run the end file configuration which you edit here in the target. Okay, but when you want to run it, you want to run it as the pre-clean. So before you clean the something, okay, you want to do something. Okay, so if you go here, okay, with a clean, just clean. Okay, so before clean is removing your target folder, everything deleting here. But before that one, you see that it echoed that the Maven task is called here. Yep.
So you said that the pre and post steps you can't call explicitly, but this way you can.
Exactly. Some of the goal you can call it, like clean you can call, okay? But things which are mentioned as a priest or post or a processor, okay? You cannot invoke it from the command line, okay? But those are the valid phases, okay? And for those phases, you have these kind of two things. So this tell that this is the Maven phase, and for this phase, you invoke this goal, and for this goal, this is the configuration of these plugin. Okay, so this is how you can go to that slide for entire Maven build lifecycle, and for every build lifecycle, you can attach to the individual plugin, okay, and then you can do whole set of stuff, okay, at the any level. Okay, I showed it clean it because like it's very small life cycle. Okay, but you can do the post packaging, pre-packaging, pre-compile, post-compile, okay, source processing, resource processing. Okay, at any phases you can do the phase binding and the goal binding. Okay, and then this will get executed at that level. So this is can show you that you can tweak the life cycle. Okay, and the Anvil is a very perfect example that if you do not have anything there, okay, and there are no plugins available, then you have a free from command sequence here from the end is the free from command sequence. Okay, you go and then put all your end sequential command, do your job. Okay, still remain within the Maven build process. You don't need to go outside Maven build process.
No need to develop the plugin.
No need to develop the plugin. Okay, you need to see what's your build sequence and then put it here. Okay, so echo is this example, hello world. Okay, but there are n possibilities. You go to the Maven documentation and then you can execute all sets of command. Okay, and then if you are doing something and then for this particular build, okay, you can add the dependencies. Okay, even it's considered like this particular build. Okay, has some dependency requirement. Okay, so this state then also goes here. Okay, because your plugin is doing something. Okay, and to execute those goals, you need a third-party jar files. Okay, so you can explicitly ask your plugin to have that you have this dependencies available. Okay, and based on this dependency, you execute it because in the Maven you can do that macros in the end macros and also have a external end tasks. Okay, that some dependency provides. So you can add also those dependencies here and execute that one this way. So this is hello world, and after that one you can tell that okay, I know Maven, I can work with the Maven, okay, and I build it. Okay, this time to update the resumes. Any questions on the hello world? Okay, so let's move further. So hello world is done. Now let's speak about the AWS. Okay, AWS CodeCommit is AWS services. Okay, Git repository like your GitHub. Okay, and exactly does the same stuff. So you can have a secured, encrypted, hosted Git repository. You can commit your code. Very cheap, doesn't charge much, and then it's with the free tier you can do a lot more. Your code registration and paying that one. It has access control associated with the AWS IAM. Okay, so you have an IAM user, and then you associate with the policies, and then based on the policies, you can control who can check out the code, who can upload the code. Also, you can use those policies, make the EC2 roles, and then associate it with the EC2 role. So EC2 can check out the code without any users. So that access mechanism is controlled by the AWS IAM. This AWS services, so it has very native integrations with the other AWS ecosystem. Okay, like the CodeArtifact, code build, code pipeline, and then entire the build system that we have, the DevOps tools that comes with the AWS services. It has very easy integration. You just provide the policies and the access control with the roles and policy mechanism from the IAM. Okay, and then without any authentication, those systems can go pull the code, build it, and check out, check in everything. If you work from outside, from the AWS, then it gets a bit tricky. I'll show you. I'm doing this everything on my laptop. So you can see, like, if you want to do it from the externally, then what you need to do. Then second thing that we're going to see in the demo is CodeArtifact. CodeArtifact is AWS Maven repository. Okay, how you your M2 is a local repository, but the CodeArtifact is Maven hosted repository from the AWS. It supports Maven structure, NPM, PyPy, NuGet, and maybe one or two others. Like the Ruby has repository now, the Go has repository. So those things are supported there. Again, it's AWS services, so have extremely tight integration with the IAM policies and control. You can provide the permissions and everything, who access the builds, who upload the artifact, who pull the artifact from the AWS. Easy to integrate with the AWS services, secure the packages access. Like this service can be connected via VPC endpoint. Okay, so within the VPC, when you pull the artifact, okay, it exactly stays within the AWS network and doesn't go even the public network. Okay, so if you are building the software within the AWS, like Jenkins and everything, then the entire your package code and artifacts exactly remain within the VPC network and doesn't go outside. So it has very tighter control. Working with this repository from the external is a bit tricky. Okay, I'll show you, and then there are some issues here that will speak when we set this one. This is very popular. Okay, so this is the ECR, which is the Elastic Container Registry, which we store our Docker container here. Okay, it's a hosted providing from the AWS. Same access control with the IAM, so you provide the policy user specifications and who access it, how access it. Easy to integrate with AWS services. You just, if you are running the ECS container or the Kubernetes services, just give your URL name, the Docker container, and then it gets pulled out and work it. Okay. It also works with the cache repository. So, like if you have a project, okay, and project is using your OpenJDK, a third-party container, then this service can also cache those third-party containers into the AWS registry. Okay, so when you run your container, it doesn't need to go and pull every time from the public network. Okay, it's available locally, so your container actually doesn't become fast. It just gets loaded immediately as within the AWS network is available, and it can execute it. It's time to see how you set that one. Okay, how you go, where is that one, what you need to do that, how you create the repositories, and we'll show how you configure the CodeArtifact as a services, okay, and then how you configure that system with your Maven build system, okay, and exactly how you configure the ECR to make the end-to-end build deployment and the container uploads from your Maven build system. Okay, so time to do the handover. Yeah, let me show you these things. So I'm the AWS console into, yeah, this is visible. Okay, so let's have here code repositories and the CodeCommit. Okay, so let's go with the CodeCommit. So this is the home page. When you go to the CodeCommit, I am in the Mumbai region. and then you go to your source code, okay, and then you see the repository. So I have created 2 repositories here for the demo purpose, and when you want to have new repository, click here, okay, my repo, just name, okay, you can add the tags here and create it. You get the repository ready, you get this check-in checkout URL, okay, and to do this check-in checkout, okay, it's exactly like the normal git command what you do with the GitHub, okay, but here you need to create the IAM user. So you go to your IAM, okay, click on your user, go to your security credentials, okay, and here at the HTTP git credentials, you create your credentials and then you download your credentials here. So it doesn't work with your IAM account, like IAM username and password, but it needs extra credentials to do the git operations. So this is what you need to create it here, okay. You also need to make sure that you have a permissions here to do that operation, okay, git check-in and check-out. I am at the administrative control, so I have like star. This is not good at best practices. You should have very tighter and the narrower permissions, only things that it needed, okay. So you get your account credentials downloaded, like from the create grid credentials, and then you get that one, and then you use for the commit purpose. So this is how you upload it. I'll do this. I have done couple of the uploads to this demo. Okay. So to do this all demo much faster, and I'll also show the end-to-end one. So this is how you do CodeCommit. Very easy. Okay. Then we go with the CodeArtifact. This is a bit tricky. Okay. So this is the default page here. You come here. Okay. Then you need to create a domain. Okay. So I have created my RV Sony. Let's create one more domain here. Okay. My domain. So simple. Okay. It asks me if I want to have my own KMS and encryption. If we don't need it, it's fine. It default encrypt with its own the keys. Okay. So now I have a domain. Okay. And that's it. You cannot do here anything. Okay. What you need to do is you need to create the repositories. Okay. So let me snapshot. Okay. Then here I have an option. Okay. So there are two kind of registries in the Maven. One is the hosted one. Okay. Where you want to save your own generated artifact. Okay. And the another registry, it called the proxy. Okay. The proxy means it is just a URL, okay, that you invoke. If your intended artifact is not available to that URL, okay, then you go to the upstream. Upstream means go to the Maven Central, okay, and then fetch the artifact from the Maven Central, okay, then cache to this my proxy server, okay. When it gets cached, then it will return it, okay. So this is the one-time process. If I'm doing it the first execution, the next execution I'll again go to the same proxy, ask the same artifact. Proxy will check that yes, artifact is already downloaded previously. I have it locally, and that time it would not go to the Maven external ones like Maven Central, or the JBoss has a repository, Spring has its own repository, those public one, and then would not download it anything. It says okay, it's ready to available, and it will just provide you. So it's reduce the fetch time. Okay, and then when the companies get set, okay, all companies have their own proxies. Okay, so you catch it locally and then you provide it within the local environment. So it saves the bandwidth and it gives you the faster output. Okay, so here it gives you the option what you want to do. So here the first is this is a Maven Central. Okay, I say okay, I will have a Maven Central there. Okay, so if the artifacts are not available to this repository, it go to the Maven Central, find it and provide me. Currently we don't want to do that one. Okay, so we go to the next. Okay, there is no upstream, it's confirmation page, boom, created. Okay, now here you see the instructions. Okay, how to interact that one. So if you go and say that I want to interact with the Maven, these are the different build systems. This is NPM is in the node, the Gridle is the Gridle with same work with the Java. This is a PIP is for a Python. I don't know what is Tween. This is a NuGet is a Windows, the .NET environment. I need to find what is the Tween here. Okay, so we want to interact with the environment. So then this gives you sets of options here. Okay, how you can get your authentication token every time. Okay, with this configuration. Okay, then how you can add this one to the profile. This is a distribution list with the profile. Okay, I have this configuration. Okay, then it also has the server profile. Okay, server configurations here to do your username and password for upload. Okay, if you want to set up the mirror, then this is a mirror configuration, also goes with the settings.xml. Okay, and this is the distribution list where you want to manually push the configurations. Okay, so consider we downloaded this whole configuration. I have it, and then we said okay, done. We are fine. Okay, so this is the configuration that you got that one. I have already shared here for the RV Sony for this demo because it took me a couple hours to figure out how I upload the artifact from the Jenkins to this repository from externally. Okay, so I don't know like spend a couple hours of that one. I'll show you exactly how I have done that one. Okay, within the parameter, and then I have created two. One is release and the one is snapshots. Okay, you can create n number of configuration here. Okay, and then you can store the artifacts. Okay, then we want to see the ECR setup. So this is the Amazon ECR, which is the container registry. Okay, let's go to get started. Okay, I already have this one created here. Okay, there is one issue with the ECR, which there is a feature request is already pending with the AWS ECR with this service. That if I want to upload my Docker image, okay, the process is that I need to create my repository first. Okay, like my Docker. Okay, and then I don't want for the KMS encryptions, I just create a repository. Okay, and then I get the configuration here. Okay, and then only I can push the Docker container to this repository. Okay, if you see the other proxies like Nexus or even the other places, okay, you when you work with the project, you don't create the Docker name first on the proxy. You just upload it, okay, your Docker file, push it, and then if the repository checks that if the Docker the tag is available, it update the tag with your latest container. If the tag is not available, okay, then it create the tag and then store your new container. Okay, here in this ECR, you need to create the repository, and in that repository, you need to upload it. And there is a feature request that I found that is pending, where people have asked that I do not need to create any of those repository names. Okay, I'll push my Docker. Okay, and then this should be get created automatically as a part of the CI/CD pipeline. Okay, if you work 10, 100,000 Docker image and like have a complex system, people won't not go to create and then take the configuration and put it there. It should be get created automatically. You can go and vote it. I'll provide you the detail. There is a GitHub issue for that. So we have created. I have this one. Okay, and I have done some of the push here. Okay, you go here and then you get these commands. Okay, like Docker build. You get the AWS login. You get the Docker pool and the Docker push commands. So I already take that one, and I have already integrated with my Maven system configurations for this demo. Also, I have configured the Jenkins to show you the end-to-end how you do that one. Everything in one shot. So let's move that. Any questions on this one?
Sir, can you perform all this step in free time?
Yes, everything is free time. AWS is very generous, gives you lots of free. Okay, even I have seen one LinkedIn post where some student accidentally created some kind of lambda or something, okay, and they did not know that they need to shut down something, okay, so they incurred $11,000 of a billing, okay. They were student, a genuine case, and they were not having the money, so they requested AWS that we don't have money, we accidentally blow up the system, and then AWS let go that everything, and then they want them, they'll not do again and let go with the billing. Okay, so AWS is very generous from that time, they give you very good configurations, and but when you do that one, okay, you need to understand few things. You understand the billing, you add your budget limits, budget warning, okay, and then you also need to each kind of like you go to the enemy line, okay, then you need to know that how you come back live. Okay, so you need to know that how you destroy the things that you have done and not left running, okay, else incur the charges. Okay.
Check your billing every day. Like
Yeah.
if
You make the budgets. There is a whole section of that one. Like you go inside, then you definitely know how you come back.
So sir,
Okay.
for performing this step, do we get charged or?
No, these are the free tiers.
free time.
But free tier has a limit, and there is a no boundary when you cross the free tier. Okay. So that is what you need to understand. That what are the exact boundary. When you create it, you need to know how to destroy that one. Okay, so you don't get extra charges, and you don't go in a $11,000 charging case, and then you need to speak and then beg AWS to let go my billing money. Okay, and I'll not able to pay it. So you need to understand, do the basics, how you create it, how you use a free tier, what are the limits. Okay, and then you can genuinely use this one. This all services comes with a free tier. Okay, so you can definitely use that one. Okay, and even you do this activity like what the demo that I am showing you here, it would not cost even $1. Okay, even you go with the paid uses, because the free tier you get the gigs of storage here. Okay, where you will do a hello world with a few KB files. Okay, so when we are playing, there is no charge here. Okay, because it's completely within the free tier, so you can do that one. Okay, so let's move quickly. Where is he? Yep. So this is the important section. Okay, this is the Maven release process. Okay, what the release process is basically like everyone works it. Okay, in general, when you do a software release, okay, the software goes with the checks. Okay, the project is in a good condition, you build it or not. You build it, then once you build it, you say, okay, software is ready, okay. Then you need to tag your source code, because you need to reproduce your build. So you need to tag the source code. You need to make the version management. You need to do the project building from the tag, okay. So the artifact that you produce is reproducible, 100%, okay. Not that you build it here, okay, and then you tag, okay, and then whatever you build it here, you produce it, you give it here. No. You tag, and from the tag and that version, you check out the code and build it here, okay, and then this release process generate the artifact, which are exactly reproducible from this point anytime, okay, and then you go and prepare for the next releases. Okay. So this is one sequence, okay, and then Maven has a way to do this entire process, okay, by just one click, okay, and then part of this process, okay, you can take the source code. So here it does the Bitbucket Git operations. Okay, then it does the project building. So it generates the artifact. At this level, it deploys the artifact. Artifact means your the code build. Also your Docker is also artifact. Okay, and then you need to again start the project for the next version. Next version is the next snapshot. Okay, so you need to go and upload and change the version and add the snapshot. No, it does everything this in the one shot, and I have a demo that I can show you this one. Okay, so now you see everything in the one action. Okay, you have Maven release process, you code commit together, upload the artifact here, upload the Docker container there. Okay, and then you do the hello world. So let's see everything in action. I have one small Jenkins setup, okay, and then the code that we have here. This is the CodeCommit, okay, this project. Okay, this is nothing, there is no Java code much, okay, just hello world, okay, and then and here, okay, so we go here, and then I need to do a one commit, not for this project. Okay, see, you can see this one. This is also interesting. Okay. See, I run this command, Maven help describe install. Okay, so it tells me that you executing this plugin. Okay, this is the plugin that I can execute, and these are all those phases of install, and what are the plugin get binds to the individual phases. Okay, so these are some of the information. Okay, the guy asked about the dependencies. Okay, so there is a command, Maven dependency : tree. Dependency is also a Maven dependency plugin. Okay, and when you call this one, okay, it check that okay, this is my main project. Then I have direct dependencies, which is starter jar, and then section by section, what are the dependencies get added here. Then there is the test jar, and then what are the test dependencies added here. I have added log4j here. Okay, so this is for the log4j, you get it here. So this is how you can inspect your dependencies. Even if you are working with the Eclipse, Eclipse also has this inbuilt facility. Okay, so I have enabled. Yes, I'll show you also this Maven section. Okay, so. So this is my AWS grid credentials. I'll use this one. Okay. Cool. Okay, then it's fine. Let me just remove one section, so we are fine here. Separately, this is done. Okay, we don't want to like get, there is some configurations need to merge. Okay, let's build it here. So if you see this one, it's let me plus this one. Okay, check out the code from AWS Git repository. Okay, I have set some of the environment here. So this is the token it generates for Maven artifact uploads. It's a bit tricky here. Then it also does automatically my Docker logging as a part of the Jenkins. Then it builds my snapshots. Okay, this is my Maven code, my test. Okay, here this build process has my Docker building. Okay, and then if you see, I have Maven deploy. Okay, and then my source code get deployed to my snapshot registry on the artifact. Okay, This is my general build process. Now let's perform a release. Okay. So Jenkins has one plugin called a Maven release plugin. Okay. So when I click, it automatically read my Maven form, tells me that what exact version that I am working currently, what is the next version that need to be rolled over. Okay, and that's it. You just schedule it. So you see this one, it's again to check out the source code. Okay, it does 17. Okay, if you see this one, it's started by my release process. Okay, this is all Git operation. It's perform a 17 step process for a preparation. It's check out the code clean. Okay, then it modify my project to the next level. Then it clean process it first. Okay, to verify that okay build is success. Once it's success, it again does my Git operations end to end with the Maven the Bitbucket code base. Okay, this is my Bitbucket AWS URL, code URL. It tags everything. Okay, git tag, git push. Okay, and then rewrite all development demos again. Everything is done. The entire Git is synced. Then it perform a release. So again, from the tag, it has checked out the source code. It start processing my exit release, okay, and then it deploy my actual release, okay. This time not in the snapshot, but if you see that this is get changed to the release, okay, and the number is finite number, okay. It's not with the snapshot, okay, and then it build a snapshot. Then this build is done. This is success. Okay, and then you have final release done. Okay, now if you backtrack this exit 0.17 version here, okay, first if we go here, okay, repository, this is what we released it. Okay, you see this one, these are all releases, and this is the exact version that we have released, latest right now. Okay, so your source code is exactly tagged here. Then the artifact is generated. Okay, so we are in the domain. Okay, I have already preset with this RV Sony. So you go, you get here release. Okay, and it says that this is the artifact and this is the latest version 0.17. Okay, if you click here, okay, then I have my previous releases also. Okay, so my code is tagged, artifact is uploaded. Okay, I also have built the Docker image. So now you come here, okay, and then you see this is my Docker file, okay. If you see this 0.17, so it has snapshot version here, okay, dash snapshot, as well as it has the same Docker file configuration with the 0.0.17. So now what I have done, I have just add that release the process.
Yes.
Okay. Code is tagged, artifact is built, releases, and now if you want to reproduce this artifact, check out the tag, okay, and then your build will be completely reproducible.
Now you have end-to-end traceability, like artifact version.
Exactly. You have end-to-end traceability, your build, code, artifact, your Docker, okay, and from this Docker, now you can take it further, okay, and then deploy it. There are some internal configurations we can that need to do. And I'll show what exactly I have done it. Okay, see, this product has nothing much. This is all some of the extra thing. Okay, so it has one parent form. Okay, the best practices that we spoke about. Okay, and if we open this parent form, okay, that must need to move my parent. This is whole sets of configurations, big list. Okay, check. I have specified my Jenkins build system, my project, my compiler version, my each and every soft plugins version here. Okay, my PMDs, everything. Then I have plugin management. Okay, then I have plugin life cycles like my assembly, how my assembly will run, jar files. This is what the Maven release plugin that we spoke about. This plugin does this one. Okay, and when we release, it's asked to invoke this profile. Okay, if you go to this profile here, okay, it comes to this profile, okay, it invokes this profile. So this profile tells that it has to build a Docker container using a zip Maven plugin, okay, and then I have OpenJDK as a base library, and this is what my intended version that I need to check upload Docker. Okay, when I need to build at the phase of package, okay, where the software is already built, okay, and then the zip has one goal, which is a build, so it executes the Docker, we build it, okay. Where you need to upload your Maven artifact needs to go with this distribution repository, okay. When I built previously, it was uploaded to the snapshot, so and that time this profile was get activated, okay, the snapshot, and then it uploaded the artifact to my snapshot repositories, okay. So on the runtime, I can switch it when I go to the release, okay, when I go to the snapshot, okay, and then when I go to the registry, okay, and then how it get built. So this is what you do it. There is one more configurations, and that is you need to tell how you want to bind your credentials. Okay, so if you just look into the quickly that one. Okay, and this is. So this is my server settings. I said that this AWS CodeCommit credentials is this one, okay, and then my CodeArtifact credentials have username AWS, and this is my environment variable, and this environment variable is getting prepared here in bit. This is the one. Okay, so this is how you tide entire process. Okay, and do it. Any question on that one? Because the next session is going to be extremely important.
I can do these things without using Jenkins. I can use code build also, right?
You can do this code build also. Even you don't need Jenkins, you can do command line.
Okay.
Jenkins is just a tool to orchestrate all those stuff.
Yes.
Okay, this all things can be done exactly over the command
So
line.
I can move these to AWS pipeline, which has code build, code deploy,
Exactly.
and it moves to code artifact.
You can do exactly all those stuff there. Okay, so the important thing that you need to now look. Okay, so we have done the hello world. We have a build. Okay, some of the next slide is very important. The cool thing that I have built. Okay, this you have done this demo. Okay, have you counted how many lines of code that you have written across the project? Okay, I have done that. There is one tool that called CLOG. Okay, you run that one, it tells you how many programming languages you have used and how many exact line of code and comments you have in the code. Okay, so I have integrated this as a part of my build tool. This is some of the very important portion that I generate the software bill of material. Software bill of material is basically like it's a packaging of your software. Okay, when this recent hack done, SolarWind, if you available everyone. Okay, the SolarWind was get hacked because of they were having dependency compromisation in the SolarWind, and then US government come with the executive order that if you are US government contractor, then you need to produce your software bill of material. Okay, either your hardware or your software project, and whenever they require, you need to submit them one to get the cross verified from the independent agencies. Okay, so I have added this end-to-end build system to generate this for every project. Then there is one more tool, dependency track integrations. I have done the end-to-end continuous vulnerability scanning for your project. Okay, then your software supply chain attack, if you have any malicious libraries in your code. Okay, if you like using a Spring jar file, okay, then Spring jar has to be generated and provided by the Spring only. Okay, if I check out the source code and modify some line, okay, I compromise it and then put it on my build system. Okay, then there is a way you can identify. Okay, so I have applied that one. I have applied open source licensing management with the SPDS. SPDS it's a kind of like a subgroup of the Linux foundation which manage all your open source licenses. So there are 489 licenses, and you need to exactly identify that if you are running a project, okay, then you are exactly within the open source boundaries, and you don't have unnecessary licensing infringements happen with your source code. Okay, so this is what end-to-end done. Okay, there is one more tool that I have integrated, which is called a license finder, and then this gives you it checks your source code and gives you the all list of licenses associated with your library. So everything is this set in the one demo. You can roll over. So this is how it looks like. Okay. You are the user, commit the code, okay, and the AWS, then goes to the Jenkins tell slave, build this project, slave check out the code, okay, it invokes the Maven build process. From the Maven, we generate the CycloneDX SBOM, which is a bill of material, okay, then this bill of material gets pushed to your dependency track project, okay, which is independent open source tool. I'll just show you how it works. That software verifies your bill of material toward the OWASP index, which is the vulnerability database, okay. Then it goes to the GitHub registry, okay, GitHub advisory database, which is a vulnerability database. Then it goes to the NVD, which is US government's national vulnerability database. Then it finds that common weakness enumerations, like if you see this, the famous one, remote injection, okay, the remote injection as a category, okay, and there is a code number. So it checks that you have that or not, okay. Then it goes to the SPDX and verify that what are the licenses that you have included in your project, okay. And then you get continuous monitoring here. You also upload the artifact to the here, okay. This is your AWS CodeArtifact. Then you upload the ECR here, okay. And then I have run this like line count and licensing finders. You push those data to those code audit DB. It is nothing but a set of tables, okay. And then you run some kind of analytic over that table, okay, to be like how many line of code that you produce, okay, how many licenses are involved in your project, okay, and this is how you build your project. So you have everything there: securities, build systems, verifications, identifications, and then alerting. So most important thing this one. I like this immediately to this one. What it does. Okay, these are the common plugins that I have used. The most important thing is this one. Okay, one thing that I disabled here, okay, that is automatic push, and I'll show you what it does. See, I have added this this plugin, okay, CycloneDX plugin. CycloneDX is one organization which define how you generate your software bill of material, okay, and when you run this one, so this section, okay, it produces one JSON and an XML file. This. Okay, it says your project, okay, the tool version, okay, then who created it, which license it includes, okay, and then what this is called a package URL, okay, you get this configuration from your build process. Then it starts with the dependencies. So you have the Spring Boot starter as a one dependencies, and this is its identification checksum. Okay, so if you these are actually the original artifacts checksum. If you modify your library, have a compromised library, then this checksum will be different. Okay, and then this tool, this one, consume this project, this JSON file. Okay, and then it's tell you that you have vulnerabilities. Okay, you have 19 components. Okay, the component, it tells you what versions are included, groups, what are the licenses that associated with. Okay, and now explicitly I added this log4j code because I want to highlight that this was compromised library and has a bug. So it tells you what is the count of your risk score. So if you have so many buggy libraries, okay, vulnerabilities libraries, you have very high risk count. Okay, and then if you go here, it shows you your dependency graph. Okay, so I have explicitly added log4j. So it tells you, okay, this is one library. I have a Spring Boot starter, and Spring Boot starter gets this many libraries. Okay, then I need to audit log4j because this log4j is compromised. How it compromised? You get the all details of your vulnerability in this tool. Okay, and if you go for licenses, okay, it's tell you that you have this many licenses, violations. In this tool, I have allowed that I can use only Apache licenses and no more that one. So these libraries are not Apache licenses. Okay, so you can identify that, okay, you have the legitimate code, you have compromised code, you have unnecessary licenses get included in your project where you should not be there. Okay, and you do this end-to-end monitoring management one shot. This is easy to integrate it. I need to fix some code, so that's why we have not done this one. But Maven has a plugin for this one. So you go here, you as a go post build and add this Maven publish bomb to the dependencies. Okay, and then you need to yes, you need to take this bomb.json, okay, and send it to this tool dependency, and then you have entire analysis for all projects. We run this for hundreds of projects, and then here dashboard, you see that how many projects are there, what are the risk scores, okay. It keeps monitoring entire project's background on a daily basis. You see it if you have suddenly some vulnerabilities get discovered, will start spiking here, and then you can configure it to send the alert to your team, Slack, email, and then and whole set of configurations here. Okay, and
so
then
you can integrate this with Jenkins. So
yes,
whenever
it is
we deploy any new build, it will check.
Yes, it checks every time.
Update the dashboard.
It checks every time we update the dashboards. It's even you don't upload the build, you already have a build system configured here. It will keep checking in the background, and whenever the new vulnerability get discovered, it will start popping here, and you will start getting email that you have something which is compromised. Okay, we'll exit this version, this project, and then you go and see, and then you will see a graph. And when you fix, okay, the graph comes down. Here there was a 0, then there was a 1 build. So I added log4j at this time, so it goes up. Now it continues. When I remove it, it comes down. So this is what you do the end-to-end with the build system.
What's the tool name? This tool.
Tool name is name is a dependency track. It's a complete open source tool on the GitHub. Okay, and it's developed by the OWASP top 10. So it's OWASP proposed tool, and then it's fully maintained very well. It tracks your vulnerabilities, dependencies, and licensing management on a continuous basis. So you just host it, you just push your JSON, configure it with the APIs, okay, and then you just need to see the dashboards. You need to alert, watch for the alerts. Whenever something gets discovered, it will check across the your body, okay, and then it will give it to you. Okay, give it to you with the exact results, like what is compromised. Okay, like here vulnerability. So this is the GitHub URL. Okay, you go, you can open that one URL somewhere. And this is all detail you get there. Everyone must have this one. These are some of the plugins that I have used. And assembly, Maven Enforcer, if you want to restrict something, you can run SQL queries, you can run EXS is very good plugin. Okay, you can do Maven Groovy plugin. I want to show you what I have done with the Maven Groovy. Okay. This is my form, okay, and yes, at some point. Not this profile, not this profile, not this profile. Yes, this one. See, I am writing hardcore Java code as a part of the build system. So you can, if something is not available, use Maven Groovy plugin, okay, and then you start writing your free from Java code in the Groovy script, and then it get executed. Okay, you can manipulate your runtime dependencies, you can manipulate the flags, you can check, here I am checking that if you have .xml SQL file is created, if created, then you execute this scopes, if not created, then you make this false, okay, and then further the code will not get executed. And if get executed, you go and then you upload the data to the Postgres. Apache admin. I have tables here. This one. This is generated from the license finder. I have all Maven dependencies, group artifact versions, and all versions included. This can track all your PyPy and all systems. You get that one, and here the output of my code. So I have this many Java files, okay, and then these are the folders, okay, and it's a number of line, number of comments, and you can have all sorts of statistics about your code, your licenses and everything in the one shot. Some of the best practices, you need to separate your build systems with the dependencies. You need to increase the use of Maven bill of material, which is what the Spring Dependency Management gets you, the Spring BOM. Okay, you need to use the parent POM. If you see this project here, this project has nothing, but I have defined my parent POM here. Okay, and this parent POM is this big. So I can control my entire company's build life cycle. Okay, how I run the individual profiles and everything. Have a centralized at one place, and then you execute that one. Okay, you add the dependency management for a parent POM. So if you have multi-module project, you need to make sure that all modules have the same dependencies. The parent POM should have the dependencies listed. You need to exactly define your plugin version, so you don't mess around, don't get unnecessary issues if the plugin change some behavior at the latest version, okay, and which is not required for you, then you will have a problem. And make use of profile. The profiles are like this ones. So this is my profile. Okay, I can add this profile name and can invoke and then invoke this plugin build lifecycle. I invoke this profile at the time of the release, and then I have my Docker get build and get my artifact get pushed. If I have a snapshot, then my artifact gets pushed to the snapshot dependencies. So based on these conditions, you can change the environment, change the behavior, okay, and then you can achieve your desired result. And then last, thank you. Any questions? Any comments for this one?
Comments, it's like it was really good.
It was still there were lots of hidden portions are there. It's lengthy. But thanks for listening and understanding. But if you do this one, then you can definitely have very good build system there. It covers your vulnerability system scanning, your licensing management. Okay, vulnerability it's a big issue. If you go and find it, Microsoft, Google, Facebook, all biggies have compromised because of their vulnerability hijacking and vulnerability issues happen recent times. So if you write a code, you must need to have this mechanism. Okay, if you have hundreds of libraries and projects, you definitely need to know where your Log4j issues are and how many you need to fix it. You just don't go and check all those projects. You need to have a dashboard, so that is also there. You do the statistics. If you making a software, you definitely need to know what are the licenses that comes with the binaries. You cannot have any libraries in your project. Okay, it's licensing agreements. Okay, and then later, if you are on the commercial space, it can lead to your the further problem. And then other, you can do the line of code, and then you can. It's kind of like start. Okay, it goes to your imagination, and by Ruby plugin, EXCC plugin, SQL plugin. Okay, you can run any kind of stuff. Okay, if plugins are not available, you build it, and then you execute it.
And even the other end, I would say, like if you have this such kind of dashboard, it gives visibility to management as well. And what
Exactly. When we got this Log4j issues, on the second week we know how many projects are compromised, okay, and how many projects need releases. We don't need to go check out the project and do the dependency injections. Immediately we started getting the alerts to the all developers. Okay, management was completely new aware that these 50-80 projects have compromised. Okay, and the next day you definitely know how you want to release it. Okay, and where exactly you want to go and fix the issues. You don't need to like go and check everything. And most of the things lies with the transitory dependencies. So this gives you the end-to-end your build system visibility. Okay, and this is how you run your the development environment. Yeah. And everything is parameterized. Okay, nothing outside of those.
So that was almost end-to-end, somewhat lengthy session, but in depth actually.
This is what you 0 to 0, 0 to hero. Now you can tell, you know Maven is depth, you can do everything. Okay, and this is what your skills is. Okay, you want to do a professional work, you need this kind of skills. Okay, and setup. Okay, so you can make sure you sleep well. Okay,
Okay.
that is what the matter is.
So thanks, and that was really nice, and I hope like that video also helped.
Yes.
Yes, my friends, some of the friends asked explicitly because they know what I have done it. So yeah, I'm able to.